Assalamualaikum and a very good day I bid to all. We are from Cluster 3 Team 6 will present the Problem 3A Progress Report. My name is Aimi and I will present the assumption part. In every problem, assumption must be done in order to simplify equation, reduce unknown and also solve the equation. The first assumption made for this problem is controller used in the control system is PID controller. Km, which is steady state gain for GM, is assumed to be 1. Next, Kv, which is steady state gain for Gv, is also assumed to be 1. Last, only top and bottom column involved in the installation of the composition analyzer. Km and Kv will later on simplify the transfer function equation. Transfer function equation for sensor we take from equation 10.3, which is GMS is equal to Km over tau Ms plus 1. Since Km is assumed to be 1, so the equation become 1 over tau Ms plus 1. For the control valve transfer function, we take from equation 10.10, which is GVS is equal to Kv over tau Vs plus 1. Since Kv is assumed to be 1, so the equation become 1 over tau Vs plus 1. The last one, transfer function for PID controller become GCS is equal to Kc 1 plus 1 over tau 1s plus tau ds. Next, for the block diagram, will be presented by Haikal. Thank you.
So my name is Muhammad Haikal and I will present about the block diagram. Okay, so for the first one, which is the top column, for this loop, it is aimed to control the composition of the methanol in the distillate flow by manipulating the reflux flow. And from this PNID diagram, we can determine three variables. For the manipulated variable, it is the LR or reflux flow rate. For the control variable, it is XD or distillate methanol composition, and the disturbance is feed flow rate or F. So for the block diagram, we will start from how to read the block diagram. We will start from here. We start from the measured variable, which is the XD. From here, you will go through a sensor where an electrical signal will be produced to the comparator, where the comparator will compare the electrical signal of the XD set point and the XD measured, and an error will be produced in electrical signal to the controller, and from this controller it will also produce electrical signal to the valve. But before it can reach the valve, it must go through a transducer where it will change the electrical signal into pressure. So from here, it will produce a new reflux flow rate, and it will go to the process transfer function, where the output will be the changes of the distillate methanol composition due to reflux flow rate. And then for this path, the feed will go into the disturbance transfer function, where the output will be the changes of the distillate methanol composition due to feed flow rate. And then both of these will produce a new distillate methanol composition, and the process will be repeated again and again in order to ensure that the XD is controlled. So for the second the second one is the bottom column, where it is aimed to control the methanol composition at the bottom by manipulating the bottom flow. So from this PNID diagram, we can determine the MV, which is the B or bottom flow rate, the control variable, the XB or bottom methanol composition, and the disturbance, which is the feed flow rate or F. So both of the block diagram have the similar block diagram only few difference. So we will also start from the measured variable, which is the xb, where we'll go through a sensor here to the comparator, where this comparator will compare the xb set point and the xb measured, and an error will be produced and will be sent to the controller, and then the controller will go through the valve, but it must pass through a transducer first, and then at the valve it will produce a new bottom flow rate, and then it will go to the process transfer function, and then the output will be the changes of the bottom methanol composition due to the bottom flow rate. And then for this one, the feed will go into the disturbance transfer function, and the output will be the changes of the bottom methanol composition due to the feed flow rate, and then both of these will produce new bottom methanol composition, and this process also will be repeated in order to make sure that the bottom methanol composition is controlled. So thank you from me, and my friend Suchi will explain about transfer function.
After understanding the block diagram of both feedback control system at top and bottom column, let's investigate their transfer function. So for top column, as our control variable is our methanol composition as distillate XD, so we need to find the transfer function of XD. So let's look at the block diagram. So here is our XD. So from the block diagram, we know that XD is equal to XR plus XF. So our XF is the disturbance, which is GDF, while for XR is equal to GPLR. In our equation, we put R instead of LR. So here LR is equal to the derivative P, and for P we know that it is equal to GCE, while for E here, from the block diagram, we know that E is equal to internal XDSP minus XDM. So our XDM is equal to GMXD, while our internal SDSP is equal to KMSDSP. So here is our final transfer function of methanol composition as distillate. We move everything with SD to left hand side so that we can rearranging the transfer function to in terms of SDSP and also F, which is our disturbance and also the set point. So here is our final transfer function in the term of SDSP and also F. So for server problem is our set point change, where we set the disturbance change equal to 0. By rearranging the transfer function, it gives us this, and we substitute the transfer function of control valve here, and also controller here, and also transmitter. It gives us the final transfer function of the server problem at top column. And while for regulatory problem is our disturbance change. Here we set the set point change equal to 0. So we arranging the transfer function, it gives us this, and by substituting the transfer function of control valve, controller, and transmitter, here is our final equation, final transfer function regulatory problem. The following bottom column will be presented by Nero.
Hi guys, so I'll be presenting on the bottom column part. So as we look into the block diagram, the methanol composition at the bottom column is equals to the mole fraction change due to the bottom flow rate plus with the mole fraction change due to the feed flow rate. So that one will be equals to the process transfer function with Rs plus with disturbance transfer function with Fs. So the Rs here will be equal to the final control element transfer function with Ps. So we will substitute that in the equation earlier. So the equation will become like this. So after this we will substitute the Ps is equals to the controller transfer function with Es. So the equation will become like this. So after this we will substitute for the Es. So the Es here will be equals to the initial set point plus with initial set point minus with measured value of x. So the initial set point here will be equals to the set points times with the steady state gain value minus with the sensor transmitter transfer function with xp. So after you substitute all the value in the equation, you will rearrange the equation. So when you rearrange the equation, you will see the term xbs here. So you bring this to the right hand side and factorize it. So after bringing to the right hand side and factorize it, you will rearrange the equation again and the equation become like this. So as you can see, this is the bottom column equation here. So for the servo problem, we know that the set point changes. So we assume the disturbance has equals to 0. So we go back to the equation earlier, which is this one. So when the disturbance equals to 0, this equation will be cut down. So we remain with this equation. So the servo problem is equals to this one, and then we substitute all the values here. For the regulatory problem, we know that the disturbance changes. Since the disturbance changes, we assume the set point is equals to 0 here now. So we go back to the equation earlier again. When we substitute 0 here, so this equation here is already taken down. So we remain with this part. So the disturbance, so the regulatory problem, the equation will be like this, and then we substitute all the values. So that's all. Okay guys, that's all from group 6. Thank you for watching. Have a nice day.